All right, class, welcome to Principles of Microeconomics, the Snow Day edition. So, as you should already have seen from my instructions, I asked that you go and watch that short YouTube video as a reminder of what elasticities are, because we're going to be continuing and finishing Chapter 4, Demand and Elasticity. So for that quick recap as well, is that we talked about the elasticity of some goods respond greatly to a change in price. So something like racquetballs are very responsive to a change in price because there's many other substitutes for sports, just like how the racquetball itself is elastic. But something like paper is much more inelastic and it won't move as much when the price changes. Okay, that's actually a lot of movement. If I throw it, it doesn't move much because there are a few substitutes for computer paper and it's a low-cost good. So we're going to continue talking about how changes in price affect change in quantity demanded. I also recommend that you have your slides out and take notes as well, since I'll be adding material to this and it'll be just helpful and a better experience. Okay. So find the slide where we're picking up on. But as a reminder, here is the definition of what elasticity is, again represented by the Greek letter lowercase epsilon. That is the percent change in quantity demanded divided by the percent change in price. And remember that we can represent it by this equation here as well, that it's the change in quantity demanded over quantity, which is the same thing as saying percent change in quantity, as well as the change in price per price, which is the same thing as saying percent change in price. Now we're going to represent this by an additional way as well. So there's a third way of representing elasticity, and that is going to be price over quantity times 1 over the slope. That's going to be the slope of the demand curve. So, one term represented in 3 different ways. Now, I'm going to go through some of the math to explain why that is. So you can follow along both here and again with the slides. All right, so here we have our demand equation represented by our typical price-quantity relationship. Again, demand curve has a negative slope. And so we're going to show that we can how to calculate elasticity just by looking at some point of price and quantity and its relationship with the slope. So we begin right here. And let me redraw this actually on a fresh piece of paper. So we have price and quantity and our demand slope here. We can begin at one price quantity point. So let's say right here, we're going to have some particular P, and let's just call that the equilibrium price and the equilibrium quantity. And we can look at what happens when the price changes. So we go from P star and it changes down to some new value. So let's call that P prime, just as a dash. So price has just dropped. And so this distance right here is the change in the price. So this total distance is P star, but this distance right here is delta P, or just the change in price. So price drops by this much, and we're going to see how that's going to affect quantity. So now we're at this new point right here, call that Q prime, and we can see that when price drops, quantity is going to increase by this much. This is our delta Q, or the change in quantity demanded. All right, so we have the elasticity. So we want to measure what is this elasticity right here at this point. And we're going to look at that point right there, which is price and quantity, that price-quantity pair, and its relationship with the slope of this line. So we're going to be able to show that we can calculate elasticity with that. So returning to our equation is that elasticity is price over quantity times 1 over the slope. It's showing that relationship. Let me also add just how that's derived. So this slide is also going into how we can calculate that. So if we use our earlier definition of elasticity, so we know that elasticity is equal to the change in Q over Q divided by the change in P over P. Now, we can separate that a little bit. So let's go ahead and just put that's also going to equal the delta Q, or change in quantity, over Q times P over change in P. So the way we were able to invert that fraction is because if we have, let's say, 1 over 1/2 or 1 over 0.5, that is the same as 2. So 1 over 1/2, we can just invert that lower fraction that's in the denominator and write it as 2. So 1 over 1/2 is the same as 2. And you can just plug this into your calculator if you're still unsure. Anyway, so we're taking what's delta P over P that's in the denominator, and we're inverting it to multiply it by here. All right, and then we can just rearrange the order. So we know that when you multiply numbers together, you can rearrange the order of how they're multiplied, and it's still going to be the same thing. So as long as we keep them in the same part of the fraction. So we can write delta Q over delta P times P over Q is going to be equivalent. Now, what we have here is that we have the change in quantity. So remember, the change in quantity is the change in the movement on the horizontal axis, and the change in price is going to be the change in the vertical axis. So really, so another way to write this is we can call the change in quantity, so on the horizontal axis, as the run over the rise. So this is just a popular way of saying this in many American middle schools, is that you can talk about the run is the change in the horizontal axis, and the rise is the change in the vertical axis. But you'll remember that slope is just the change in the rise over run, but we have run over rise, so if we invert that, so that's the same as 1 over rise over run times P over Q, or, which is equal to 1 over the slope times price and quantity. So this first slide is just showing how we go from this equation of elasticity to a different definition. So these are equivalent, but they're showing us something very interesting here, that we can calculate the elasticity from a particular point as well as from that slope of the line that that point is on. So now let's go ahead and do that. So we can just look at it and say, okay, if we have some particular point A, and we know to kind of put numbers in here, if the price is going to be 8 right here, and if the quantity is 3, and the slope, so change and rise over, so the rise over run, if the slope is equal to 4, now note that this is negative, so it's actually going to be -4. But because for elasticity, we're not concerned about the price for elasticity of demand, that we don't always put that negative sign. So just remember that the slope actually is negative, but that's why we're disregarding the negative right now. Okay, and then once we have those points, then we can just plug the values into this equation. So price over quantity of 8 over 3 right here times 1 over the slope, or 1 over 4, we can calculate that at this price point, that the elasticity is 0.67. And if you remember, that a value of less than 1, an elasticity of less than 1, we will call inelastic. So for this good, if we calculate the elasticity of 0.67, that is an inelastic good, like paper, that does not change, where the quantity demanded does not change much with the change in the price. All right, so let's keep going on with that. So next we have, two different demand curves. And we can see that even though at this point, the price-quantity relationship is the same. So we have a price of 4 and a quantity of 4 at this point. So that's not changing. However, elasticity is the combination of price and quantity with the slope of the demand curve. So we can look at what happens if there's 2 demand curves. Now, if you have this printed out in black and white like I do, then it's kind of hard to see that these are different colors. You can look at the electronic version on e-learning to distinguish them, but we have the something with a higher slope right here is going to be the less elastic. So actually, let me get a highlighter. So that line with the steeper slope is going to be less elastic than this other demand curve, which is going to be more elastic with the more shallow slope. Now, also keep straight that these are just 2 different demand curves. We're not talking about supply yet. Supply we will get more into in the next chapter, but this we're just talking about the price elasticity of demand. So this is just really just a summation of what we've talked about, that elasticity is considering at one particular point of price and quantity and its relationship with the slope. And then we can see that the slope is going to be the same for that entire, if we just have one demand curve, the slope will remain the same, but at each point on that demand curve, there is going to be a different elasticity at each point. So if we have one demand curve that points A, B, and C, oh, that spelling's terrible. Let's just keep that as demand. That point A at this price and quantity will have one elasticity. At this price and quantity, at point B, it will have a different elasticity. And at this price and quantity at point C, we will have a third elasticity, because the price and quantity are different for each point on here, even though the slope has remained the same. Okay. So moving on, if you remember how we represent elasticity and inelasticity, is that anything, if we just take a number line between 0 and infinity with the point 1 right here, anything that is in this region between 0 and 1 in absolute value is inelastic. Anything greater than 1 we'll say is elastic. And then at 1, a good is unit elastic. Okay, so that's just representing this on the number line, but we can also observe how this changes on our demand curve. That at different points on the demand curve, a good will either be inelastic, unit elastic, or elastic. So let's look at that. Let's see if I can keep both. And the video cut out. So here we are with part 2 of the Snow Day edition of Chapter 4, Microeconomics. All right, so we want to talk about 2 special cases of elasticity in our demand curve. And the first case is going to be what happens when elasticity is infinite, and then the next is what happens if elasticity is 0. So let's have a look. So for a good with the price elasticity of demand that's infinite, that would be a good where there's just lots and lots of substitutes for it, where if you just change the price even by a penny, then people will completely stop purchasing that good. So we talked about peas being an item that has a higher elasticity because there's substitutes of other frozen vegetables, but also that if one person changes the price, peas are peas. You'll just buy frozen peas from somewhere else. So the price elasticity of demand is infinite, which means price is pretty much fixed here. We can see that no matter at different quantities demanded, the price is just staying the exact same. And so that is what the demand curve will look like in a case of infinite price elasticity. And similarly, we can see that if the price elasticity of demand is 0, that the quantity demanded is fixed. So that's not going to change. And it doesn't matter what the price is, that the quantity demanded is going to be the same amount. So that could be an example of something like a life-saving medication, where no matter what the price is for this medication, you're going to have to purchase it. So the price can go up and down a lot, but you're just going to demand the same amount. Maybe something like illegal drugs that are highly addictive can also fit into this, that can be have 0 price elasticity of demand. And we can see this again if we go back to our equation of what happens if the slope is 0. And if the slope is 0, it's, this term will be undefined, and it's represented like this. When the slope, oh, I'm sorry, that's 0 slope. Or if the slope is infinite, then this term will be 0, and we'll have a demand curve like this. Anyway, so you will have to know, though, that not necessarily how the slope or what different values of the slope mean that, but just that an infinite price elasticity of demand is a horizontal line, and a 0 price elasticity of demand is a vertical line as your demand curve. Okay, so now let's talk about how total expenditure is going to be affected by this price elasticity of demand. Okay, so because we're talking about the demand side of this equation, we're talking about total expenditure. If we were talking about the supply side, it would be total revenue. However, what we're interested in often is this equilibrium point. So if the supply curve goes through that equilibrium point right here, then what's going to happen is that supply will equal demand, or total expenditure will equal total revenue. So often we're going to talk about cases where these two terms are equal, because that's equivalent to saying demand is equal to supply. All right, but let's keep talking about the impact on total expenditure, since this is a chapter on the demand curve. So we see that as the price increases, the total expenditure can either increase, decrease, or remain the same. All right, so as consumers, we are interested in what the total expenditure that we are spending on goods and services is going to be. So total expenditures we can calculate as price times quantity. So imagine that we're just talking about a single good here. Yeah, all you have to do is multiply price and quantity, and that'll get what your total expenditures are. And we can see this graphically as the price right here. So if the price is 2, we can see that the size of this area, the height is 2, and the quantity is demanded is going to be 4. And so the total expenditure, the area of this rectangle, is going to be 8. So let's say we're at this point, and from here we're able to calculate not only total expenditure, but that when price changes, what's going to happen to this total expenditure. And we can see that if the price rises, let's say to 3, what is that going to do? Let's see, the way this is drawn, it makes me think that a price of 3 will result in a quantity demanded of 2. And so if the price goes up, we can see that total expenditures will go from 8 to 3 times 2, which is equal to 6. So total expenditure in this case, if price goes up, will actually go down. But let's talk about some different examples with this. So if movie ticket prices increase from $2 to $4, so it goes from point A right here to point B, a place that is slightly higher, something like right there on this curve, but it's just also shown over here. And in this case, we're talking about the whole market for movies. So it's not just an individual, it's the entire market. So it's total expenditure for all those people within the market. And so we can see that at a price of $2, total expenditure was $1,000 a day on movies. So 2 times 500 is simply 1,000. So this area, which represents total expenditures, is 1,000. And if it goes up from $2 to $4, shown over here, then we can see that the quantity demanded has decreased, which we would expect because of the law of demand. So as the price goes up to $4, quantity demanded goes down to 400 tickets per day. And so with this, the new total expenditure is simply, again, price times quantity, which is 4 times 400 and is equal to $1,600 per day as the new total expenditure. So in this case, from an increase in movie prices leads to an increase in total expenditure. However, let's look at another example. Now imagine that the movie tickets were originally $8, so that is the initial amount of $8. So here, again, just multiply price times quantity, is that you're going to have $8 a ticket times 200 tickets a day will result in $1,600 of total expenditure. And that's at this point on the demand curve, Y. But what happens if the price increases here? So if the price increases from $8 to $10, we'll see that the quantity demanded goes from 200 tickets a day to 100 tickets a day. And at that point, the new total expenditure of $10 a ticket times 100 tickets a day is $1,000 of total expenditure, represented again by that area or that square under the curve, rectangle under the curve. So in this example, even though the price is increasing, the total expenditure is decreasing. So this all comes down to what is the elasticity at each point on the demand curve. And it's that elasticity at that point that's going to determine how a change in price is going to affect total expenditures. So we can apply this to some case like the market here, where we talk about the movie ticket expenditures for everyone in the market, but this can also be an individual, and we can talk about an individual's demand curve. But either way, just because a price is going up or down, we can't necessarily say what's going to happen to total expenditures unless we're able to know a specific point on the graph. And this all comes down to elasticity and the equation we talked about with that. All right, now let's look at this in a different way. So here, we're still talking about our example of the price of movie tickets. And we have our demand curve represented as this downward sloping line. And at each point along this curve, we're able to calculate, yes, we would even be able to calculate the elasticity at each point. However, right now, we're just going to look at what happens to total expenditure at each price point. So let's say that there's only one movie theater in town, and they're able to set the price because they have a monopoly on movie theaters. At what point would the movie theater want to set a price that maximizes consumers' total spending on movies? So we can look at this for each particular price. So first, we just start with $12. So $12 right here, represented at this point on the line, there is 0 movie tickets demanded at a price of $12 a ticket, because that's outrageous. And so we can see the same point. So we can see this point of all right, so we just talked about identifying this point right here as the price of $12 and how on our typical demand curve it relates to this point right there. Now we're introducing this new chart here, which is showing what effect a price change has on total expenditure. So on the vertical axis, we have total expenditure measured as dollars per day, and on the horizontal axis is price. Now be careful, because price over here is the vertical axis, and now we're representing it on the horizontal axis. But what we see broadly is that as the price increases, there's going to be some maximum point at which total revenue or total expenditure is at its highest point. But initially, we'll start at 0. So at the beginning, there'll be 0 total expenditure, and then eventually, if the price is high enough, then it'll also become 0. So, okay, so price of $12 is associated with this other end of the graph here. So $12 would be this point, because the quantity demanded at $12 is 0, so total expenditure is 0. Now, if the price is $10, the quantity demanded is going to be 100 tickets per day. And so the total expenditure for a price of $10 and a quantity, ooh, that's a typo right there in the slide. So this should be 1,000, thousands of tickets per day. So, oh, no, never mind. That's quantity. Okay, sorry about that mistake. There's an extra digit here. So these should all be just hundreds, because the quantity demanded at a price of 10 is 100. And so 10 times 100 is 1,000. Okay, math checks out. Great. Sorry about that mistake. Anyway, so at a price of $10, total expenditure is 1,000. So here, we see that a price of $10 is coming up to here and is a total expenditure of $1,000. And as we can see, as the price decreases, it's getting higher and higher. So the price of, this is $8, shown right here, price of $8, quantity demanded is going to be 200 tickets, and that's total expenditure of $1,600. And then it looks like we have a maximum point for a price of $6. So here we are at a price of $6. We have a point in the line where quantity demanded is going to be 300, which is a maximum, which is the maximum total expenditure of $1,800. So we can see that then after this, if the price continues to drop, total expenditure will also drop. And eventually, if you charge $0 for tickets, then you're going to have zero revenue, and so you're back with a total expenditure of $0. So this curve, it's showing that you can start at $0, reach maximum, and then go back to $0 in terms of total expenditure as shown in its relationship with price. All right. So the idea with all of this, actually one more note back to this. If you've taken more advanced math, the relationship between these two graphs is that this graph on the left is just the derivative of this. So if you've taken calculus, you'll understand that you can take the tangent of a point and that'll be represented by a value here. So a lot of economics deals with rates of change, so calculus comes up a lot. However, for this class, you don't need to know that. It's just more of a fun little factoid. All right, so the idea from this is, again, that we're showing that due to the elasticity of different points of the demand curve, that it has different effects on what the maximum total expenditure is going to be. And that total expenditure is different for each price point. So for the profit maximizing firm, they'll want to choose the price that will result in the highest total expenditures. Now, this of course is assuming that that a company is able to choose the price. We'll talk more about that in the next chapter and what ability firms have to set a price. But if they can, they'll obviously want to maximize the total expenditure of customers. So they'll choose this. But the elasticity shows that different changes in price result in different total expenditures. That if you raise the price, it's not always going to result in higher expenditures, because as we can see, as price is increasing here, for this part of the graph, it is starting to increase, but then after this price, it's decreasing. So it's not always beneficial to raise the price. And this is going to be shown here, and it's represented in different ways. That, that when you have, because total expenditure is coming down to the product of price and quantity, that it really depends about which is having a bigger effect. Is the price effect larger, or is the quantity effect? So when you change the price, if quantity decreases a lot more than a change in price, which happens when a good is elastic, then overall, the price quantity product is going to decrease. So let me say that again. If a good is inelastic, then when the price goes up, let's say 1%, and the quantity demanded decreases by, let's say, 2%, then in this case, it's elastic because quantity demanded is reacting more than a change in the price. So if the quantity demanded changes more than the price, then overall we'll see a reduction in total expenditure. And so again, this is relating to demand, because in demand, the relationship between price and quantity is negative. Okay, so let's flip this. Let's say the price goes down by 1%, and the quantity demanded goes up more by 2%. Again, this is an elastic good, so we would expect this. Then overall, the total expenditure is going to increase. Now, when a good is inelastic, one thing we note is that it's inelastic when its elasticity is less than 1. So this is actually a mistake that I found in the book, and it's also present in both the print and online version. So just make an important note that this is a typo that is in the book, and it should be that the elasticity is less than 1. Because as you remember, on the number line, so elasticity between 0 and infinity, this is the inelastic region, this is the elastic region, and then we have the unit elastic at 1. So less than 1 is inelastic, greater than 1 is elastic, and 1 is unit elastic. So this really should be that the elasticity is less than 1. All right. Okay, so when a good is inelastic, the price effect is greater than the quantity effect. So price changes more than quantity. Again, let's say we have a 1% increase in price, and the quantity demanded only goes down by 0.5%. Then in this case, total expenditures will increase because the price of a good is going up more than the quantity demanded is decreasing. So the net, P times Q, is going to result in a higher number here for total expenditure. And then similarly, 1% decrease in price would result in an increase in quantity demanded, but if the good is inelastic, so again, 1% decrease and a 0.5% increase is going to result in total expenditure decreasing. So that's the main ideas of the price elasticity of demand. And as I had mentioned before in an earlier class, there are other types of demand. Other types of elasticity. So we're talking about the price elasticity of demand, where we're looking at the percent change in Q of some good, let's say good A, over the percent change in the price of that good A. So when the price of one particular good, like apples, increases by 1%, what is the change in quantity demanded of apples? So that's the price elasticity of demand. So now we're going to introduce two other kinds of elasticity. And these both will relate to demand. So let's keep that within view. Ooh, not too... Okay, so we also have the cross-price elasticity of demand. And with the cross-price elasticity of demand, I think it's actually easier just to show us the equation. So the price elasticity of demand is showing the percent change, how it relates in percent change in quantity for good A as it relates to the percent change in price for good A. But the cross-price elasticity of demand is when what happens, so if there's a 1% change in the price of good, let's say B, so there's some other things like bananas. If the price of bananas increases by 1%, how is that going to affect the percent change in the quantity demanded of apples? And this is the cross-price elasticity. So yeah, so it's something that is applied a lot to goods that are substitutes and complements. So again, substitutes are goods that they substitute each other. So that you would choose between apples or bananas, but usually not, you don't want both because you already have some kind of fruit. And then complements are goods that you want to have together. So like peanut butter and jelly go together. So you want to buy those things as a pair often. So the cross price elasticity of demand. So here's the word definition, and I had already written the mathematical definition. So the verbal definition is it's a percent change in quantity demanded of good A as a 1% change in the price of good B. So 1% change in the price of good B as it relates to the percent change in quantity of good A. And so what would we expect from the cross price elasticity of apples and bananas? So we'll just talk about the signs instead of the magnitudes. So the signs are that if these two goods are substitutes, so let me put that up there for apples and bananas. So if the goods are substitutes, they will have a positive cross-price elasticity, which makes sense when you think about it. So if the price of bananas goes up, then you're not going to want to buy as many bananas, and instead you'll buy apples. So if the price of bananas increases, then you will also see an increase in the quantity demanded of apples, because those two goods are substitutes. Now, if you look at something like peanut butter and jelly, then if the price of peanut butter, so let's do, so 1% change in the price of peanut butter. If the price of peanut butter goes up, then the amount or the effect that will have on the demand for jelly, there's my J, is going to decrease. So if the price of peanut butter goes up because you're also buying jelly with that peanut butter, then that's going to have a negative effect. So you'll have a positive effect, and a negative effect, which together will just be negative divided by a positive will result in a negative effect. So here, for substitutes, they'll have a positive cross-price elasticity. And then for complementary goods, so goods that are complements like peanut butter and jelly, they will have a negative cross-price elasticity. And the last elasticity of demand we'll talk about is the income elasticity of demand. So income elasticity of demand is defined as the percent change in quantity demanded from a 1% change in income. So if income, percent change, we'll use I for income, if the percent change in income goes up by 1%, what is going to be the percent change in demand, in quantity demanded for a particular good, again, good A. So when income goes up by 1%, how is that going to impact the how is that going to impact the percent change in quantity demanded for good A, like apples? And this is the income elasticity of demand, which again, remember, elasticity is always dealing with the responsiveness. When there's some kind of price change, how does quantity demand, how is that affected by that price change? Now, in this case, it's really a change in income that's affecting quantity demanded. Now, we can also talk about some particular goods. So a normal good, which actually apples would be a good example. So for a normal good is that as you receive more income, you will likely buy more apples. So as income goes up by, let's say, 1%, usually, so say it's positive, a positive change in income will result in a positive change in quantity demanded. So that's showing that the income inelasticity of demand for apples is going to be positive. Now, let's talk about an inferior good. So an inferior good is something that when you earn more money, you want less of that good. So let's say we'll talk about McDonald's. McDonald's is known as being a fast food place that's not that good. And yeah, if someone has more money, they'll probably go to Chick-fil-A. But anyway, so we can talk about if they have a 1% change in income. So if income goes up by 1%, we'll say that's positive, then what's going to happen to the quantity demanded of McDonald's? Use M for McDonald's. Usually if someone earns more money, they are less likely to go to McDonald's. They'll go to a different fast food place, or maybe they'll say, or they'll like go to a nicer restaurant, but they'll likely eat less of McDonald's because McDonald's is generally known as an inferior good. So again, what is the responsiveness of the change of one item for another? So today in this video, we talked about, just more of the price elasticity of demand. We looked at how we can calculate that from the slope of the demand curve. Let me bring that up.